Welcome friends, we are back to the third episode of Vectors. I am Sanjay Agarwal and these are Sanjay Agarwal maths classes. So this is episode number 3. The chapter is Vectors, class is 12 and the subject is maths. So we have already done 2 episodes, each of 30 minutes. This is the third episode. We will carry forward from where we left in the previous episode. If you are joining for the first time, please do watch episode number 1 and episode number 2 so that you are able to understand episode number 3. If you try to understand episode number 3 straight away, you may face some problems. So in the last class, we learned how to add 2 vectors using triangle law of addition or parallelogram law of addition. When you add 2 vectors, you always add them as per a specific rule, triangle law of addition. It is not 2 plus 3 is equal to 5. 2 plus 3 could be 1, 2 plus 3 could be minus 1, 2 plus 3 could be any other number also. So, it is not normal addition of numbers. So, let us take 2 simpler cases. Suppose I have 2 vectors in the same direction. This is one vector, this is another vector. The magnitude of this is 2, the magnitude of this is 3. Now, if I want to add them, I will get a vector in the same direction but of magnitude 5. So, if 2 vectors are pointing in the same direction, it is very easy to add them. You just add their magnitudes and retain the direction. And if they are pointing in the opposite direction, this is vector 2 and this is vector 3. So, here you are going to subtract the numbers and direction will be that of the bigger vector. So, it will be like this and the magnitude will be 1, not minus 1. Magnitude of a vector can never be negative. So, if they are pointing in the same direction, you simply add. If they are pointing in the opposite direction, you subtract from the bigger number the smaller number, you get the magnitude and the direction will be that of the vector which is having a greater magnitude. But if they are pointing in some inclined direction, neither parallel or anti-parallel, so this is vector of magnitude 2, this is a vector of magnitude 3 and they are in certain direction. Now you add them like this. So this will be the sum, but you cannot tell me their direction, you cannot tell me their magnitude just by looking at the diagram. So there are specific formulas to find the direction and the magnitude that class 11 students in physics do. In maths we do not need to do it because we are going to adopt a different approach for finding the sum of the 2 vectors when we are going to express the vectors in terms of unit vectors along x axis, y axis and z axis. So, but if they are pointing in the same direction, I can quickly give my answer. If they are pointing in the opposite direction, again I can quickly give my answer. But if they are pointing at some other angle, then I can't quickly give you what will be the resultant, that is the sum of these vectors, what will be the magnitude of this vector, the resultant vector, or what will be the direction of this resultant vector. I can see on the blackboard, I can see the diagram, I can say this is the sum of these 2 vectors, but what is the magnitude, what is the direction, it won't be easy for me to tell you. I will have to do lot of geometrical stuff here, draw a perpendicular, make it, I need to know this angle, I use Pythagoras theorem, I use trigonometry, then I get my answer. But again, the beauty of this in class 12 maths is that we do not need all this knowledge. What students used to do in class 11 physics. We are going to represent vectors in a different manner and then adding and subtracting will be just so damn simple for us. Now, is it possible to add 2 unit vectors so that their sum is also a unit vector? Normally you will think how 1 plus 1 can be 1, but in vectors it is possible. See, I will show you with the diagram. This is a vector, say magnitude 1. This is another vector, say magnitude 1. Now, sum of these 2 vectors will be like this and I want this to be 1. So, yes, it is possible. This has become an equilateral triangle. So, if I add a vector of magnitude 1, I add vector of magnitude 1 with another vector of magnitude 1, then their sum can also be of magnitude 1 of a certain direction, but then this kind of diagram will be there. This angle will be 60 degrees, but this will not be called angle between the vectors. So, we will come to it later. So, what I am trying to say is that yes, in vectors it is possible to add 2 unit vectors and get their sum also as a unit vector. So, there will be a specific numerical on this, we will come to it later. So, I took 3 cases when vectors are in the same direction, when vectors are in the opposite direction, and sum of 2 unit vectors. Can it also be a unit vector? The answer is yes. Alright. So, now we are going to go to the next topic, not multiplication of 2 vectors, multiplying a vector by a number. So, that will be called scalar multiple of a vector. So, you can say that today's class starts from here. What I did was a last portion of the previous episode, episode number 2, and this is episode number 3. The topic now, you can say this is the beginning of the class, scalar multiple of a vector. Scalar multiple of a vector, or I can say multiplying a vector by a number. This number can be negative or positive or even 0 also. So, suppose I am given a vector A. Alright. So, this vector has a specific magnitude as well as a specific direction. For some reason, you want to multiply this vector A by a number 2. So, how do I do that? So, I simply write 2 in front of this. So, this will be called multiplying vector A by a number 2. You cannot put any symbol between the 2 of them. Okay? If you feel like, you may put a bracket like this, you may put a bracket like this, but you can't do this, this is wrong, and you can't do this, this is also wrong. These symbols have very specific meaning and are reserved when we are multiplying 2 vectors. So, when I multiply 2 vectors, then I put this dot or a cross between them. Dot and cross cannot be put between a vector and a number. Between a vector and a number, we just don't put anything. If you still feel like putting something, make a bracket, but not dot and cross. So, be very careful about this point. So, multiplying a vector by a number, vector A, you are multiplying with 2. You have another vector B, you want to multiply it by -3. So, just write down -3b. You have another vector, say C, you want to multiply it by 1 by 2. So, you just write it like this. You want to put a bracket, put a bracket. You don't want to put a bracket, don't put a bracket, but don't ever put dot or cross between a number and a vector. That will make it meaningless. Alright. So, this topic is called multiplying a vector by a number or multiplying a vector by a scalar. Now, the next natural question arises. What does it do to my vector? When I multiply a vector by a number or when I multiply a vector by a scalar, both means the same thing, that scalar or number can be negative also. So, when I multiply a vector by a number or a scalar, and what I get, what is this stuff? Is it a vector or is it a scalar? So, the answer is, when you multiply a vector by a number which could be a negative also, what you get is also a vector. So, this is a vector -3b, the arrow will be only on b, not above 3, 2a, half c, these are all vectors. And if they are vectors, then what? Obviously, they will have magnitude and direction. So, let us now study what will be the magnitude of vector 2a and what will be the the direction of vector 2a. So, 2a is a vector because I just now told you, when you multiply a vector by a number which could be a positive number, negative number or even 0, if you multiply a vector by 0, you will get a null vector. Alright. So, when you multiply a vector by a number, what you get is written like this, what you see on the blackboard, and this is a vector, it will have magnitude as well as direction, because every vector has a magnitude and direction. So, what will be the magnitude of this vector? And what will be the direction of this vector? Alright. So, magnitude of this vector will be written like this, because these 2 vertical bars, which is the modular symbol, also represent the magnitude of the vector. So, magnitude of this vector will be mod of 2. When you put these same number, vertical signs on a number, it will be called modulus. When you put on a vector, it is called magnitude. So magnitude of vector 2a will be mod of 2 into magnitude of vector a. Mod of 2 is 2 only, so it will be twice the magnitude of vector a. So what happens? Suppose the magnitude of vector a was 10, so the magnitude of vector 2a will be 2 into 10, that is 20 units. So magnitude of vector 2a will be mod of 2 into magnitude of a, that is 2 into magnitude of a. Alright. Now I can make a formula for you. Suppose lambda is some scalar. It could be positive, negative, and this is the vector a. Let me write on this side. This might go outside the screen. Alright. So lambda a, this is a vector. What I have done? I am making a formula for you. Please remember it. I will be using it in the numericals. I have vector a. I multiply it by some scalar. I am not giving a specific number. This number lambda represents a number which can be positive or negative or maybe 0. Now I want to find the magnitude of vector lambda a. So the formula for this is mod of lambda into magnitude of vector a. Please remember it, okay? I will be using it very often. So when you multiply a vector by a scalar, you do get a vector, and that vector will have a magnitude and a direction. So this is the formula of the magnitude. Alright. Now what will be the magnitude of minus 3b vector? So what is the symbol? This is the symbol. What is the formula? Look at this formula. So this will be mod of minus 3 into magnitude of vector b. What is mod of minus 3? Everybody knows it. What's mod of minus 3? 3. So it will be 3 times the magnitude of b. See, magnitude of a vector can never be negative. So minus doesn't mean that this vector has a negative magnitude. Minus only indicates that the direction of this vector will be opposite to that of direction b. So what is the magnitude of minus 3b vector? Mod of minus 3 multiplied by magnitude of vector b, that is 3, mod of minus 3 is 3 times the magnitude of vector b. So if vector b magnitude is 5, minus 3 magnitude will be 3 into 5, 15 units, or you simply say 15, you do not have to say units. So if the magnitude of vector b is say 7, magnitude of this vector will be 3 into 7, 21. So now you know the formula. So when you multiply a vector by a scalar, it will be a vector, its magnitude will be given by this formula, mod of lambda into magnitude of vector a. Now let us talk about direction. I hope this is clear to you. What will be the direction of vector 2a? The direction will be same as that of vector a if scalar is positive. Now there is no space to write below this, it will go out of the screen. So direction of vector 2a will be same as that of vector a, and I am not writing, I am just going to speak. And direction of minus 3b, because scalar here is negative, so I will say the direction will be same as that of vector a if the scalar is positive. It will be opposite to vector a if the scalar is negative. So what is the magnitude of this? 3 times the magnitude of vector b. And what is the direction of this vector? Opposite to that of b. Whatever direction b is having, minus 3b will be a vector whose direction will be opposite to b. So I wrote one more example. This is vector c. I multiplied with 1 by 2. Now this is also a vector. What will be the magnitude of this vector? What will be the magnitude of this vector? Half times magnitude of vector c. अगर इसका magnitude 20 है, तो इसका magnitude हो जाएगा 10. What will be the direction of this vector? Since this is a positive number, direction of this vector will be same as that of c. If I multiply it with minus, now this vector will have magnitude 1 by 2 times magnitude of vector c. It won't be minus. 1 by 2 times, suppose the magnitude of vector c was 10. So magnitude of this vector which I have drawn in a circle will be 1 by 2 into 10, that is 5. And the direction of this vector will be opposite to that of vector c. So now you have understood, alright, how do I multiply a vector by a number, also called scalar. I don't put dot or cross between them, I just put them side by side. And when I multiply a vector by a scalar, is it a scalar or a vector? It's a vector. If it is a vector, it will have a direction and magnitude. So I have explained what is the magnitude, what is the direction. Please do remember this formula. That is the reason I put it in a box. Alright, let's take some interesting examples on the same topic. Alright. So what is I cap? I told you in the previous class, those students who are watching this video for the first time should definitely go back and watch episode 1 and 2, but I'll tell you for your benefit. I cap represents a unit vector along x-axis pointing in the direction in which the x coordinate is increasing. So what is the magnitude of this vector? 1. Now for some reason I multiply this vector by 5. Alright, so this I don't put dot across here. So what does 5i represent? Is it a scalar or it's a vector? So 5i represents a vector. So I hope you permit me to have some coffee here. So what does 5i represent? 5i represents a vector. Alright, I told you when you multiply a vector by a number, it will be a vector. So what will be the magnitude of this vector and what will be the direction of this vector? I am sure a lot of students will very quickly give me the answer. Magnitude of 5i cap will be mod of 5 into magnitude of I cap. Mod of 5 is 5 and magnitude of I cap is 1. So answer is 5. So 5i cap is a vector of magnitude 5. What will be the direction? Since this number is positive, direction shall be same as that of vector I cap. And what is the direction of vector I cap? It's along x-axis in the direction in which the x coordinate is increasing. So 5i cap is a vector of magnitude 5 parallel or along x-axis pointing in the direction in which the x coordinate is increasing. Let's take another example. Minus 2j cap. Is it a vector? Tell me please, is minus 2j is a vector? Yes. Minus 2j is also a vector because you are multiplying a vector by a number and that number can be negative. Now the question arises, what is the magnitude of this vector and what is the direction of this vector? So I am sure almost all of you will know the answer even before I tell you, but some of the students might have joined today, so they will take some time to adjust. Again I am requesting you, please do watch episode number 1 and 2 and then watch this episode. You will be much better off to understand. See, this is a symbol of magnitude. So what is the magnitude of minus 2j cap? Mod of minus 2 into magnitude of vector j. The same symbols are spoken in a different way depending upon the context. When you put these vertical bars or vertical lines on a vector, I will call it as magnitude. When you put it on a number, I will call it as modulus. So magnitude of vector minus 2j is modulus of minus 2 multiplied by magnitude of vector j. What is the modulus of minus 2? 2. What is magnitude of vector j? It's a unit vector. There is a special symbol also I cap. The moment I put a I cap on a vector, it represents, what does it represent, friends? It represents a unit vector. So it will be 1. So the magnitude is 2. 2, not minus 2, 2 times magnitude of j, that is 1. And what will be its direction? Because the scalar is negative, direction will be opposite to the direction of unit vector j cap. So minus 2j cap is a vector whose magnitude is 2 and direction is opposite to that of j cap, means it is along or parallel to y axis but pointing in the direction in which the y coordinate is decreasing. Okay. Now we go to the next topic. So slowly we are now moving towards algebraic representation of vectors, where I am going to represent every vectors in terms of I, j and k. From that moment the class is going to become much more interesting because my numericals will be based on them, and this is the foundation of that. Alright. So what did we do in this class? The topic of today's class, the major topic of today's class was multiplying a vector by a scalar, or I can say multiplying a vector by a number. Now the next topic is to prove two vectors parallel. Alright, fine. Now, how do I prove two vectors parallel, or if two vectors are given to be parallel? I told you in the first episode, parallel means in the same direction, anti-parallel means parallel but in the opposite direction. But in the broader sense, for parallel vectors, we can have vectors in the same direction parallel to each other or in the opposite direction. So, instead of using different words for parallel and anti-parallel, we will use parallel vectors in a broader sense, that vectors are physically parallel pointing in the same direction or pointing in the opposite direction. How do I prove two vectors parallel? So, I am giving you a theorem which I will explain you. If vector A is parallel to vector B, then you can write down A vector as some scalar times vector B. First I am going to give you the formula, then I am going to explain it. So, if vector A is parallel to vector B, then you can write A as some scalar B, that is A is equal to lambda B. Lambda is the symbol for some scalar. I will call this rule, I am going to use it very often, I will call it as ASC golden rule. This is no official name, but I am going to represent or speak this very important concept as ASC golden rule. So, in the future episodes you are going to watch, if I say what is ASC golden rule, you should be able to recall that it means this: if A is parallel to B, then you can write A as some scalar multiple of B. So, when I am doing numericals, I come to one stage A is parallel to B. In the next line I will write therefore A is equal to lambda B. Therefore, A is equal to lambda B. So, this is a very important concept. Alright, so you must remember it, and hence I have written it as ASC golden rule, and I am going to use it in the reverse direction also. Suppose I end up proving A is equal to lambda B. I end up proving, I am doing some numerical step by step, I come down, the last line is I prove A is equal to 2B, or I prove vector A is equal to minus 3 of vector B, or A is equal to 5 times B. When I say A, I mean vector A. Vector A is equal to 5 times vector B. Then what inference can I draw? So, if you end up proving A is equal to lambda B, then the inference you can draw is vector A is parallel to vector B. So, this theorem, which I am going to now refer it as ASC golden rule, will be used in both the directions. If it is given to me A is lambda B, A is parallel to B, I will write down therefore A is equal to lambda B. If I prove, or it is given to me that A is equal to lambda B, lambda means some scalar, maybe positive, negative, then I will draw an inference, they are parallel to each other. Please do remember this theorem. Let us call it as ASC golden rule, so that when I use it again and again, I will say please recall ASC golden rule. What does it imply? I will again repeat, if A is parallel to B, you can infer A is equal to lambda B. Conversely, if A is equal to lambda B, you can infer A is parallel to B. Now, how do I justify this rule? You see, let me draw a diagram to you. This is vector A, alright, let me make it longer, and this is vector B. Do you see them parallel on the blackboard? Suppose the magnitude of this is 6 and the magnitude of this is 3. Are they equal? No, because they have different magnitudes, but they do have the same direction. Now, suppose I multiply B by 2. Now, what is the magnitude of vector A? 6. What is the magnitude of vector 2B? 2 times magnitude of 3. What is 2 into 3? 6. Now, the magnitude of vector A is 6. Magnitude of vector 2B is also 6, and they are pointing in the same direction. So, can I say they are equal? I did tell you. What do you mean by equality of vectors? Two vectors are said to be equal when they have the same magnitude as well as the same direction. Direction I can see on the blackboard, they have the same direction, but their magnitudes are different. But now their magnitudes are equal because I multiplied vector B by 2. So, magnitude will be 2 times 3, that is 6. So, what is this? So, if two vectors are parallel, A is some scalar multiple of B. Let me take another diagram. I will rub it off. See, this is a vector of magnitude 6. Let me call it as A cap. This is another vector B of magnitude 3, but they are in the opposite direction. Are they equal? Obviously no. Their magnitudes are different, their directions are different, obviously they are not equal. But if I multiply this vector b with minus 2. Now, is this a vector? Yes, when you multiply a vector by a scalar, you do get a vector. What will be the magnitude of this vector? Mod of minus 2, that is 2, times the magnitude of vector b. What is the magnitude of vector b? 3. So, 2 times 3 is 6. So, this is a vector whose magnitude is 6. What is the direction of this vector? Opposite to that of b. B is pointing in this direction, so minus b will point in this direction. So, this will become equal to a, because now minus 2b will be this vector. Magnitude 6 pointing in the direction opposite to that of b. So, now I can say a is equal to minus 2b. Magnitude of this is 6, magnitude of this is 6, both are pointing in the same direction, that is a is some scalar multiple of b. So, if you are able to write a some scalar multiple of b, you can safely draw an inference that the vectors are parallel. If lambda is positive, they are in the same direction. If lambda is negative, they are in the opposite direction, but they are still parallel to each other. And conversely, if a is equal to lambda b, you can infer they are parallel, or if a is parallel to b, you can say therefore a is some scalar multiple of b. Alright. So, this is will now in future will be referred to as, it will be referred to as ASC golden rule. Now, let me do the last topic of today's class, section formula. And the next episode will be the one for which we all are eagerly waiting, that will be algebraic representation of vectors. So, before that, let us finish this formula, section formula. For internal division, I will just simply give you the formula, we are not going into its derivation. You have a line segment, let it call it as A, let us call it as B. Now, what is the position vector of point A? Episode number 1 or 2. What is the position vector of point A? Vector OA. Those who have already watched it will know it, will give the answer quickly, and those who have not watched, obviously are going to watch it now. So, position vector of A will be vector OA, and how do we write it? This also I told you, because if I physically want to write OA or show OA, I will have to draw x axis, I will have to draw y axis, I have to draw z axis, I have to mark origin, I have to take a scale, join origin with A, put an arrow towards A, and then physically I will see vector OA. We do not do so much of hard work, we do not do so much of drawing. So, position vectors of points are represented below the point in a round bracket by the symbol we want to give to the position vector of A. And what will be the position vector of B? OB. Now, you want to find position vector of point P. What will be the symbol OP, which divides it internally in the ratio of m is to n. You have done this formula before also in lower classes as well as in coordinate geometry. So, what is the target? I am given a point A whose position vector is given to me OA, I am given a point B whose position vector is given to me as OB. I want to find the position vector of a point P which lies on AB and divides it internally in the ratio of m is to n. So, what is the formula? You are going to remember it like this. It will be right into left, m times into position vector of B. So, m times OB, and I told you, when you are multiplying a vector by a scalar, you do not put dot or cross, at the most you can put a bracket, plus n times position vector of A divided by m plus n. So, this is the formula you are going to remember. It is very easy to remember, left into right plus right into left divided by m plus n. This is for internal division. Alright. If it is for external division, I will come to it. Now, let us do a corollary of this formula. Suppose P is the midpoint of EB. So, what will be the ratio? 1:1. So, I can call it as midpoint formula. I am writing point as shortcut PT. So, what will be the midpoint formula? So, this is my line segment B, A, position vector OA, position vector OB, P is the midpoint. So, if P is the midpoint, ratio will be 1:1, and what will be OP then? Position vector of P will be called as OP, M 1 times OB plus 1 times OA. So I can write it as OA plus OB upon 1 plus 1, that is 2. So I can roughly say it as it is the average of the corners. You add them and divide by 2. So the midpoint of line segment AB will be having a position vector which will be the average of the position vectors of the endpoints OA plus OB divided by 2. And for external ratio, I am going to rub it off here. You can note it down from the video in your exercise book. If you are finding that you are not getting sufficient time, you just listen to me with full attention. After that, once the episode is over, you can re-watch it, you can pause it, and then you can write it in your theory copy. Alright, I will advise you, all of you, to make a theory copy. Just in that theory copy, you write all the salient features, all the formulas. Don't solve any numerical in those copies. In that numericals, you can make a separate copy. In that way, in one consolidated exercise notebook, you will have all the theory in one place. So it will be very easy for you to revise. So be cautious, don't mix your theory with your numericals, make a separate notebook for your theory. Now for external division. In external division, P does not lie on AB. P lies before A or after B on the line AB produced. But for the sake of writing the formula, you can draw a diagram of internal division. Of course, it is a wrong diagram, but at least your formula will come correct. So for external ratio, you draw line AB, mark your ratio which is given to you like this. Otherwise, the actual diagram is like this. This is A, this is B. So P will lie either on before A or after B, depending upon what kind of ratio is given to you. In external ratio, it becomes PA upon PB is equal to M by N. Here also PA upon PB is M is to N. You speak this alphabet before. Don't say AP by PB. It is better to say PA upon PB is M upon N. So whether it's a diagram of external ratio or it's a diagram of internal ratio, it will be same if you speak P earlier. So PA will be extended portion, PB will be complete portion. In the internal division, PA will be this part of the line segment, PB will be this part of the line segment. So therefore, otherwise if you say like this, AP is to PB, it will be correct here, but here it will go wrong. PA is to AB, that's wrong. External division means extended portion PA and the complete line including the extended portion. So PA is to PB. So if you write P alphabet first, whether it is this diagram or it is this diagram, you will not go wrong. PA is M, PB is N, ratio is M is to N, PA is M, PB is N, ratio is M is to N. Alright, so in external ratio, what I do is, I draw the same diagram. I don't draw the actual diagram because that becomes confusing. Instead of plus in the formula in the numerator as well as denominator, we put a negative sign. So whether it is internal division or external division, I make the same diagram. Only thing is internal division, I will put plus here. In external division, I put minus here, and this is the midpoint formula. If you have to find unknown ratio, then instead of taking M is to N, we will take it as K is to 1. So for unknown ratio, we don't take M is to N, we take it as K is to 1. Use the formula, find the value of K. If K is 2 by 3, my answer will be P divides AB internally in the ratio of 2 by 3. Suppose my K comes minus 2 by 3, the inference will be P divides, this point P divides AB externally in the ratio of 2 is to 3. So there are two kind of numericals. They will give you OA, they will give you OB, they will give you the value of M, they will give you the value of N, and you will be required to find the position vector of P. So you are going to use this formula. For external ratio, you will put minus. For internal ratio, you will put plus. Other kind of question is that they will give you OA, they will give you OB, they will give you OP, and they will say in what ratio P divides AB. In that case, don't assume ratio as M is to N, you assume ratio as K is to 1. Apply this formula, you will get the value of K as a fraction. If it is a positive fraction, it is internal division. If it is a negative fraction, it is external division. We will say P divides AB internally in the ratio of 2 is to 3. we'll say P divides AB externally in the ratio of 2:3. So we'll end the class here. Now a very small topic is left, centroid of a triangle, and then we start the algebraic representation of vectors. This is what we are waiting for, because that's going to be very interesting, very easy to understand, and that is what is going to be used while solving numericals, not what we did in all these 3 episodes, but still I did teach you this so that you have fairly good idea what exactly are vectors, because non-physics students are slightly at disadvantage as compared to the students who have done or who are doing physics. But now once you go through episode number 1, 2 and 3, you will be as smart and as good as your counterparts who had physics in class 11. So bye for now. We will see you in episode number 4, where we will start with centroid of the triangles and then the algebraic representation of the vectors. So have a nice day, and of course do write your comments and don't forget to subscribe and hit the bell button. You obviously do not want to miss the future lectures on vectors and the subsequent chapters of class 12 maths. So I am Sanjay Agarwal signing off for now. See you soon in episode number 4 of vectors. Bye. Have a nice day.